Welcome to a lesson with Dr. Powell. Let's take a look at a little description of why, if something is a right inverse, a matrix inverse, it's also a left matrix inverse. Well, let's make an assumption. Let's suppose that A and B both have right and left inverses, meaning that their Smith normal form is the identity matrix when you can get that by row or column operations somehow. Okay, so it's an identity matrix of some kind. So if it has a Smith normal form and we can get it by row operations or column operation, row operations are only column operations, then we definitely have a left and a right inverse. So it's kind of like saying, the row operations matrix and the column operations matrix, right? That we use in order to get the Smith normal form, are these the same? Is kind of what we're asking, and is it unique? Is another question we can ask. Well, first of all, would the right inverse and the left inverse be the same? Well, suppose, if A has a right inverse, let's say it's B, and B in and of itself, representing an isomorphism, we can think of it as having left and right inverses too, and let C be its right inverse. Then we could go through a little thought exercise. A and B is the identity. So what if we multiply both sides by B? You get B on this side, and then you can multiply both sides by C on the right, and you get BA is equal to the identity as well, which means that B is both. So if B is a right inverse, it definitely must also be a left inverse in this case under these assumptions that we have made. Also, let's think about this. What about uniqueness? So we can say, okay, well, in this case, so if we have a right inverse, it's also a left inverse and vice versa. So we could just say it's an inverse, but our inverse is unique. So let's suppose that A has two inverses, and we proceed as follows. So we can have A times one of the inverses is going to be equal to A times another one of the inverses, and it's going to be equal to the identity in both cases. Okay, now we can multiply on the left by, in fact, we could pick either one of these inverses since they're both right and left inverses. We could just notice that if we just did B2, multiply by B2 on the left, we could even do over here, but we don't really need to. Now, if we did that, this is the identity. Notice what we have. We have B1 is equal to B2. They're actually equal to each other, which means it was unique in the first place. So for matrices, if a matrix has both a right and a left inverse, both of those right and left inverses will be the same. It'll just be an inverse, and it'll be unique. There's only one that it could possibly be. Thanks for watching.